Hi everyone, welcome back to General Science Class 6th. So in our previous video, we have discussed about the first chapter of General Science, which is our food. I hope you all have watched that video, and if you didn't, please watch that video for the first lesson of General Science, our food. So in this video, in our second video, we are going to discuss about the second lesson of General Science Class 6th, which is playing with magnets. Yes, so in this lesson we are going to discuss about magnets, which we are very familiar of in our daily life. So I think when we are kids, okay, we most of you played with the magnets. So most of you, so you have seen the magnets in different equipments like some objects. So for example, I will give you some examples where you can find magnets in the daily life. Okay, for example, you can find magnets whenever you go to any offices like government offices or banks. There you can see on the desk of the officer, there you can see a small box which is called pin holder. Okay, there you can see on the pin holder cap, the iron pins are getting attached to the it. Okay, they get attached to the cap of the pin holder. Okay, next I will give you one more example. Suppose if you go to any dumping yard where we can see a huge amount of waste materials are are piled onto huge heaps. There you can see a device called or a machine called a crane. Okay, so the crane, it contains one hand, and to this one hand, so it hangs a rope. So to the one end of the rope, there you can see a block like structure, and this crane, it would move the block onto the heaps of these waste materials. So when it is moved onto the heaps of these piles, so the iron objects would stick onto this block. Okay, so I will give you one more example. I think you might have seen in your homes. Okay, so you will stick some badges like structures onto the walls of the refrigerator or onto the almaras. Okay, so those badges, so they will get stuck onto they will get stick onto this refrigerator door or almara door. Okay, so in these three examples, these are the common examples that we can say. So like this, there are so many different examples I can give. So but in these three examples, first example, a safety pin cap or safety pin box which is placed on the desk of an officer, and the second example, a crane which has a block, okay, which attracts the iron objects towards it, and the third example, the badges which are stuck onto the windows or doors of almaras or refrigerators. In these three examples, so the cap of the safety pin, so cap of the pin holder, it contains magnet, and the block of a crane, it contains a magnet, and the badge which is stuck onto the uh, door of the refrigerator, it also contains magnet. So that is the reason why, so they are stuck onto certain objects. Okay, mostly iron objects. Okay, so in these three example, we can see magnets, and we can also find magnets in some different objects like speakers. If you open any kind of a sound speaker, there you can see a round black color structure which is called magnet, and we are all familiar with the magnets. Okay, you might have played with the magnets in your earlier days. So when you bring any iron object towards or near the magnet, the iron object, it will get attracted to the magnet. Okay, so magnet is a substance which will attract certain types of materials. Okay, so in this lesson we're going to discuss about magnets. We will discuss about how this will attract other objects, and what are the objects which are getting attracted by these magnets, and also we will discuss some properties of the magnets. Okay, so actually in olden days, so the magnet was naturally obtained. Okay, so but in today's world, okay, we are the magnets are prepared by humans. They are man-made, so they are called artificial magnets. Okay, so now there are different types of artificial magnets based on their shape. Okay, so here I have provided few of them. So types of magnets. So first one, bar magnet. Okay, it would look like this. So it will be along a straight line. Okay, next ring magnet. So it is like this. So there would be a hole in the middle. And horseshoe magnet. Okay, horseshoe magnet is in U shape. We can also call this magnet as U-shaped magnet also. Okay, so next one, disc magnet. So it is also round in shape, but there is no hole. Bar magnet, ring magnet, horseshoe magnet, and disc magnet. So these are the different types of magnets actually. So now actually we know that the magnet, it will attract certain types of materials. Okay, so those whatever the materials which are getting attracted by the magnet, they are called magnetic materials. For example, iron, nickel, cobalt, etc. These are the materials, they will get attracted to the magnet, and they are called magnetic materials. And those magnets which are not attracted by a magnet, they are called non-magnetic materials. For example, paper, wood, a cloth, etc. So these are called non-magnetic materials. They won't get attracted to the magnet. Okay, and if you want, you can perform an activity in your home. You can take a magnet and you can take different objects, and you can check whether these objects, when they bring near this magnet, whether they are getting attracted to the magnet or not. So whichever the objects they get attracted to the magnet, they are called magnetic materials. I mean, those objects are made from a magnetic material. For example, if you take a safety pin, if it gets attracted to the magnet, so we call that the safety pin. It is made out of iron or steel. So like this, so there you can use different objects, and you can find whether they are attracting to the magnet or not. The objects which are getting attracted by the magnet, they are made out of magnetic materials, and the objects which are not attracted by the magnet, they are made from non-magnetic materials. Examples for magnetic materials: iron, nickel, cobalt. Examples for non-magnetic materials: paper, cloth, and wood. Okay, so next, so let's perform a small activity with a magnet, and with this activity, we are performing this activity to find out what a magnet contains actually. So now, to perform the activity, we require a few things. One is a magnet, obviously. It can be a bar magnet or anything. Okay, and it can be available in outside markets, and you can purchase it. Next, so we need a magnet, and we need some iron pieces. Okay, and we need a paper. Okay, now first what we have to do is, we have to take a paper. For example, we have to take a paper, and we have to spread some iron fillings onto the surface of the paper. We have to spread it all around the paper. Okay, next, we have to take the magnet. For example, if this is a magnet, we have to take the magnet, and we have to place the magnet just below the paper. Okay, next what we have to do is, so we have to observe the change in the pattern of the iron fillings or iron pieces on the paper. So as soon as you bring the magnet so near this paper, below the paper, you can see, so the iron fillings, they are changing their pattern. The iron fillings, they get separated into 2 points. They get separated into 2 groups actually. So some of the iron fillings, they move to the one end, they move to one point, and other iron fillings, okay, they will move to the other point. The iron fillings, they get separated by some distance. So here, this pattern has changed. This change of pattern has occurred because of the magnet which is placed below the paper. Understand? So the magnets, okay, so sorry, the iron fillings, they get separated because of the ends of the magnet actually. Okay, so the ends of a bar magnet or any kind of a magnet, the ends of a magnet, they have more strength of magnetic power. That is why some of the iron fillings, some of the iron pieces, they move to one point, and some of them move to the other point. They moved exactly to the ends of a magnetic material, actually magnet. So they move to the ends of a magnet. Okay, so here from this, what we can say, what we can understand is that, so the magnetic strength is more at the ends of the magnet than the middle part. The magnetic strength is more it seems to be more magnetic power at the ends of a magnet than the middle part. Okay, so here at the ends of the magnet we say that there exists some poles. Okay, actually this strength, so the magnetic power is more at the ends because the ends contain some poles. They are called poles of a magnet actually. So that means each pole for each end. So that means a magnetic contains actually two ends, that means two poles, each pole for each end. Okay, so let's just discuss about another property actually. So now we have discussed, I've told you that a magnet contains two ends and at each end there would be one pole. So now let's discuss about another property of a magnet actually. So that is called directional property. So to discuss about this directional property, so we actually have to perform an experiment, and to perform this experiment, and we also need few things. So one is magnet. Here, this one you can assume it as a magnet. You can assume it as a magnet, and we need a magnet, a thread, and a stand. Okay, we have to arrange all these things in this apparatus. Okay, here you can see, so with the help of this thread we just hung this magnet onto this stand. Okay, so here what we have to do is, when this magnet hung onto this stand, next what we have to do, we have to observe, we have to before we hang this magnet onto this stand, what we have to do is we have to put a mark onto either of these ends of the magnet. Here I've put here the mark on one end of the magnet. We have to put mark on either of the ends of a magnet. Okay, it doesn't matter which end we will choose. Okay, so here I kept the mark on one end of the magnet. So when I hang this magnet onto this stand, okay, we have to allow it come to rest position. Okay, so when it comes to rest position, then what we have to do is we have to mark the points on the ground, so on the ground, on the stand. Okay, so we have to mark the points on the stand in such a way that, so these points will show the direction in which the magnet has pointed or came to rest position. Understand? Okay, so here one end shows this point, this shows one end of the magnet, this point it resembles another end of the magnet, and then we have to join this line. We have to join these 2 points forming a line. So this line shows the direction in which the magnet has come to rest position. Okay, so again we have to repeat this activity by just moving this magnet, okay, with a small amount of push. We have to push the magnet, or we have to move it with a gently touch, and we have to again observe, okay, at which position this magnet has come to rest. Okay, whenever it comes to rest, we have to again locate the points, we have to take the points, we have to mark the points, and again we have to make a line. And if we repeat this activity several times, so we will come to know that, okay, we'll come to know that, so all the time, okay, the magnet has come to only one particular direction. We will get only one straight line in all the cases. We can only get only one straight line. That means, so a freely suspended magnet, when you freely suspend a magnet in air, okay, without exerting any kind of force or without stopping it, okay, it will comes to rest position in only one particular direction. Okay, so this is actually, in this experiment we can observe mainly two things. One is, the magnet, when it comes to rest position, it always stops in one direction. Understand? Okay, that is the one thing. And another thing we can observe this, so either of these two ends will always come in only one direction. Okay, and so this direction in which the magnet has stopped, it seems to be actually stopped in a north and a south direction. These are the two things that we can observe. One is, a freely suspended magnet will always comes to rest in one direction, and that direction would be north and south direction. Okay, so here the end which shows shows the direction of north, it contains north pole, and the end which shows the direction of south, it contains south pole. Just now we have discussed about a magnet contains two ends, and each end it contains one pole. So now here, after this experiment, the end which shows the direction of north, it contains north pole, and the end which shows the direction of south, it contains south pole. So that means how many poles will a magnet have? It have two poles, that are north and south pole. And this means from this activity what we can say that, so a freely suspended magnet will always comes to rest in the direction of north and south. Okay, so this property is called directional property. Okay, yes. Okay, so we have discussed about a magnet which has two ends contain two poles, one pole at each end. Okay, so now for example, this is the magnet. I will show you here. You can see a magnet here. So this is a bar magnet. So one end contain one pole and other end contain other pole. So the end which whenever we suspend a magnet in freely in air, okay, it will always comes to rest in north and south direction, right? That's what we have discussed about that's what we have concluded after performing the previous experiment. So the end which shows the direction of north, it contains north pole, and the end which shows the direction of south, it contains south pole. Here magnet contains north and south, so another magnet north and south, and here the magnet has kept reverse south and north. So like this you can see each magnet, it contains two ends, at each end only one pole, either south or north, south pole and a north pole. And the magnet, so the end which shows the direction of north, it contains north pole, the end which shows the direction of south, it contains south pole. Next, so let's just that is actually that property, whenever you freely suspend a magnet in air, it always comes to rest in north and south direction, right? So that property is of a magnet is called a directional property, and directional property can be used so in device called compass. We all know what is meant by compass. So this is how a compass look like. Okay, so it contains a magnetic needle which is placed here, which is pivoted just in the middle. So you can see here they have given some markings: north, west, south and east, and in the middle it contains magnetic needle. Okay, so when you place this compass at any particular place, so the place where you want to know, so the directions of north, south, east and west, so the magnetic needle, it will always shows the direction of north and south. Okay, so with the help of this compass, where we can use a magnetic needle here in the compass, we can find the directions of north, east, west and south. Okay, the directional property can be used in the north compass. Okay, so the directional property, it can only be exhibited by, it can only be shown in, we can only see that that property only in magnets. We can't see the property in any other objects or any other materials. So the directional property can only be exhibited by magnets only. Next, so we will discuss about another property of a magnet. So for example, here you can see, so this one, so please see this picture, this one, first one, there is one magnet, there is also another magnet. So here you can see one magnet contains two ends and each end one pole, north and south. Another magnet, it also contains two poles, and one is north and another one is south. So here in these two magnets, so here the south pole of one magnet and the north pole of another magnet, they are called unlike poles, because one is south and the one is north, unlike poles. Okay, here you can see, so here, but if you take north pole of one magnet and north pole of another magnet, okay, so they are like poles. North pole and north pole are like poles, south pole like poles, but north pole and south pole unlike poles. Here north and north like poles, south and south also like poles, but south and north unlike poles. North, south, like poles, north and south or south and north, unlike poles. Okay, so here, so if you take any two magnets and if you bring the poles of these two magnets together, so we can observe one special type of behavior here. If you bring unlike poles together, if you bring unlike poles of any two magnets together, we can see they will get attract. The unlike poles of a magnet always attract. But if you perform the same activity, okay, so with the like poles, that means south south pole or north north pole, they will repel. Here you can see I have shown attraction and repulsion with the help of arrow marks. Okay, arrow marks here, south pole and north pole, that means unlike poles attract. Okay, so these two magnets, they will attract. So here also north pole and south pole, unlike poles, so here they will get attract. Okay, so here south pole and south pole, that means unlike poles, they will always repel, they won't attract, they will force to move away. Okay, so here this is called repulsion here, north pole and north pole, and similarly like poles. So here also in this case, north pole and north pole, since they are like poles, they will repel. So attraction and repulsion properties can also be observed in magnets. Okay, so attraction unlike poles, repulsion like poles. Here, so let me write here, attraction unlike poles. That means south pole and north pole or north pole and south pole, they will get attracted. Next, repulsion like poles. Okay, so like poles will always repel. So here south pole, north pole, like poles, they will repel. Okay, so this is one important property of magnets, attraction and repulsion property. So next we will discuss about another property which is called magnetic induction. So to know about this magnetic induction, we can perform a small activity, and this activity requires three objects. One is a magnet, and another one is a safety pin and an iron nail. Okay, so here you can see, for example, if you take safety pin and an iron pin, and if you bring this iron pin and touch it onto the safety pin, will this iron pin get attracted to this safety pin? No. Why? Because either of these objects are magnets. Safety pin is not a magnet, and as well as iron pin is not a magnet. So that means they won't get attracted to each other. Okay, so but if you perform this activity with a magnet, okay, here if you take a safety pin and if you bring it near the magnet, so the safety pin will likely to get attracted to this magnet. It will get attached to this one end of the magnet, and when this safety pin is in contact with this magnet, and if you bring the iron pin near this safety pin and if you touch it onto the safety pin, the iron pin will surely get attracted to the safety pin. Okay, so that means here when the safety pin is in contact with the magnet, the safety pin itself acts like a magnet. Okay, but as soon as you remove the contact here, if you just separate this magnet and the safety pin, the iron pin, it will fall down. So here from this experiment, what we can say the safety pin or any magnetic material, when it is in contact with magnet, it itself acts like a magnet. Okay, so that means the magnetic property is produced in the magnetic material when it is in contact with the magnet. Okay, so this is called magnetic induction, the production or the possession of the magnetic property by a magnetic material when it is in contact with a magnet, that is called magnetic induction. And you can perform this activity in your home also, so with the help of a magnet, safety pin and an iron pin. Okay, so these are the main topics in this lesson, playing with magnets. So once again I will recall these points. Okay, first one is different types of magnets. So there are different types like a bar magnet, horseshoe magnet, ring magnet and a disc magnets. These are all artificial magnets. And next we have discussed about a magnet has two ends and each end a pole consists. That means total 2 poles A magnet always contains two poles, and a freely suspended magnet will always comes to rest in the direction of north and south, and that property is called a directional property, and it is used in a device called a compass. And next we have discussed about attraction and repulsion. If you bring unlike poles of any two magnets together, so they will attract, that is called attraction property. And if you bring any like poles of any two magnets together, they will repel each other, that is called repulsion property. And next we have discussed about magnetic induction. So these are the main points here. So if you want to know any more about playing with magnets, you can refer textbook, and please watch this video again and again for the better understanding. Okay, I hope you all have understood. Have a nice day. Take care.